Hello viewers, in my first video on circles I've explained the theorem that a tangent to a circle is perpendicular to the radius through the point of contact. And in this video I'm going to explain the second theorem of this chapter, that is the lengths of tangents drawn from an external point to a circle are equal. As you can see, this is a circle with center O. And P is any point outside the circle. This is the circle and this point is P, which is outside the circle, and I have drawn two tangents PA and PB. What we are to show in this theorem, that length of PA and PB are equal. Let me now show how to prove this theorem. As you can see in this figure, I have taken center as O and P is the external point. So we can write, let PA and PB be two tangents drawn from an external point P to a circle with center O. Okay, so what we have written, PA and PB are two tangents drawn from an external point P to a circle with center O. Now in this theorem, what we are to prove? We are to prove that PA equals to PB. So we have to write here, to prove PA equals to PB. PA equals to PB. I think this much is clear. Now to prove this, we need some construction. That's why I have joined PO, AO and BO. These three I have joined. In the construction, we have to write PO, AO and BO are joined. So PO, AO and BO I have joined. Now in proof section we can write, since the tangent at any point of a circle is perpendicular to the radius through the point of contact, This theorem I already proved. So we know this is one tangent, this is another tangent, and this one are the radii of the circle. So this angle will be 90 degree perpendicular, this one also will be 90 degree. Clear? So since the tangent at any point of a circle is perpendicular to the radius through the point of contact, so we can write PA is perpendicular to AO. Therefore PA perpendicular to AO and PB perpendicular to BO. Clear? This one is perpendicular to this one is perpendicular to this, because these two angles are 90 degree, as I have explained in the first theorem. Therefore I can write, angle PAO equals to angle PBO. Both will be 90 degrees. So we can write here 90 degrees. Okay, we can write equation number 1. Now in triangles OAP and triangle OBP, OAP and OBP, angle PAO equals to angle PBO, each 90 degree from equation number 1. Okay, so this angle is 90, this angle is also 90. Now PO is the common side and AO equals to BO, so we can write here PO equals to PO common and AO equals to BO, radii of the same circle, and radii of the same circle must be equal. Okay, therefore we can write, triangle OAP congruent to OAP congruent to OBP by right angle hypotenuse side congruency. You can write by RHS congruence. And we know when two triangles are congruent, their corresponding sides must be equal. Therefore, we can write PA equals to PB by CPCTC. Corresponding parts of congruent triangles are congruent. So since these two triangles are congruent, therefore this side must be equal to this side. Hence proved. Okay, let me just revise here. Here O is the center of a circle and PA and PB are two tangents drawn from an external point P. We are to show PA equals to PB. For this, we have done some construction. We have joined OA, OP and OB. As PA is a tangent and AO is a radius, so this angle will be 90. Similarly, this angle also will be 90. Now, in these two triangles, PAO and PBO, this one is 90, this one is also 90. PO is common and AO equals to BO. So, by using congruency rule, RHS congruence rule, right angle, hypotenuse, side, right angle, hypotenuse, side, these two triangles are congruent. And since triangles are congruent, so PA equals to PB, because we know corresponding parts of congruent triangles are congruent. Okay, I hope this one is clear. Just we have to prove that this triangle and this triangle are congruent, then we can conclude PA equals to PB. I hope this theorem is clear. Just go through it. And that's all for today. In the next video, I'm going to show sums of chapter 10. Till then, bye-bye.